Hey, once again, AP Calculus BC students, Mr. Record here, and we are going to take a little dive into some power series and more importantly, more specifically, we are going to talk about how to use an infinite geometric series to quickly depict a power series. And in this particular problem, we're going to do so for the function f of x equaling -2 over x plus 3, but we want this to be centered at 3. Now, the underlying principle about this is to be able to develop a power series that looks very, very familiar to you all. Hopefully at this point in your study of calculus, you've seen this particular series and the fact that this series is equivalent to a over 1 minus r. That is your traditional infinite geometric series. So we should be able to take this function f of x and rework it to have this form right here. And it's likely that you may have done this before with some other problems, possibly centered at 0, where they're a little bit easier. But if you want to center this one at 3, it's not real difficult to do, because all you're going to do is you're going to dive into this and you're going to say, well, if I want this to be centered at 3, I'm going to make that happen. So we'll just rip the x out and replace it with x minus 3 to give it that look of being centered at positive 3. Now we still have the plus 5 that we bring down, and then we also realize that, wait a minute, we can't go around doing this and subtract 3, so we'll compensate by quickly adding 3. And now we've got something that is equivalent to the previous expression, right? If you just cancel these 3's, you get right back to having x plus 5. Now if we work on this a little bit more, namely adding the 5 and 3 together, maybe writing that first, we start to look at this a little further and say, does that really look like this guy? And the answer to that question is really it doesn't. For one thing, this number 8 has got to change and become a 1. Well, that's pretty easy to do. We're just going to divide the top and the bottom all by 8. So we probably have something that looks a little bit like this. And at that point, this would simplify to be -1/4 on top over 1 plus the quantity x minus 3 all over 8. But we still don't quite have that look that we're going for. We don't have this subtraction sign happening. Well, that's a pretty easy fix. We are just going to manipulate that sum to be a subtraction, which would then allow us to bring out a negative, and whoops, we've got the quantity here, x minus 3 all divided by 8 with that negative out in front. Now we're all set to go. Now we have what we need to write this particular expression right here, which is going to be our power series. So this is going to become the summation as n goes from 0 to infinity, and our a value would just be the numerator, -1/4. And then we'll have our r term, which is negative x minus 3 over 8 to the nth power. And that sort of completes the initial look of our power series, although it's quite often when you see situations like the negative within the quantity that's raised to the nth power that you can extract a -1 to the nth. And what that essentially does is it gives the power series more of an alternating look to it. And thus we could probably leave it like that. Sure, there are some other things that you could do to kind of manipulate it just a little bit, but for all intents and purposes, that's pretty much, I think, the most common way that you would see these presented on, say, even a multiple choice question. And you'll notice these particular directions, they don't ask you to find the interval of convergence, but if you were to do that, you could just very, very quickly take this r value here and place it inside of absolute values and set it less than or equal, just strictly less than 1. And then you could choose to even simplify that. But for the purpose of this video, we were just talking about developing that power series. So that's it. Anytime you've got to write a power series using a sort of a geometric approach and you're not going to be centered at 0, that's the way to do it. Anyway, hope this video helps, and I'll see you at the next one.